Thank you everybody for coming today, and I'll begin with some introduction of myself, but I'll try to keep it short. As you can see, my name there is a Welsh name, and in English I'm used to pronouncing it Bryn Llewellyn, and Bryn is very easy to pronounce, I'm sure. When I lived in Norway, I was known as Llewellyn, and I'm quite used to that. And you can, by all means, say that if you like. I'm a product manager, and I'm lucky enough to work at Oracle headquarters. As product managers go, I would say I'm at the very heavyweight technical end. Not many days pass without me typing up some PL SQL or SQL for some purpose. But I never have the luxury of doing that for any real, actual project that's going to do something somewhere in the running real world. Rather, I'm always aiming to illustrate this, illustrate that. And that gives me a particular perspective on the code I write. I'm trying to make it as tiny as possible and all sorts of things like that. It's a very unusual situation. But nevertheless, I would say that I know my PL SQL inside out, back to front and upside down, and I do my EBR as well. I'll say a bit more about how I'm doing both in a moment. But the other thing I'll just say to give you some background about me is that I've been with Oracle for a long time. I moved to headquarters in the mid-90s, and after doing something different, I started off with PL SQL in the early 2000s, and I've been with EBR since the split second we started talking about it, long before it was ever released in a product. And the special gift I, let's say, enjoy and can bring to you is that on the floor that I work, which is the middle floor in the tower which is devoted to the database, that's where all the brain power about SQL compilation, SQL semantics, I should say, SQL compilation, SQL execution, the optimizer, PL SQL language definition semantics, the compiler, PL SQL execution, the joint operation of the two, the library cache, all that stuff, multi-tenant too, partitioning too. It's all done on the floor where I work, and all the brain power you've heard about, like the famous Mohammed Zait, for example, who does the optimizer. He's next door but one to me, and I'm lucky enough to be able to go and speak to all these people if I need some explanation of something. Especially, why is this like this? Couldn't it be like that? That kind of thing. So I've got the kind of inside story, and particularly I've got the inside story about EBR, and quite unashamedly, let me tell you what I propose to do today. Until the very end, you won't see a shred of code, and don't expect to see the slides changing frequently either. I might put up a slide just to have some illumination coming off the screen, and then speak just in a kind of extempore fashion for maybe an hour without any visual aid. And what I believe is that I can bring you something unique, what you couldn't find by reading, because no one's written it, and what you'd have a hard time deducing. But what I can tell you is why things are like what they are, and various conceptual aspects which will guide your use of the thing. You'll understand why it's like this, why it can do this, and why it's the best thing on the planet, the only thing on the planet for doing this, why it wasn't designed for doing that, and if you think you could use it for that, it'll end in tears, that kind of thing. And I've, let's say, I've had many conversations with many people who've been interested in it and seen many of them get off on a kind of wrong track of thinking. And the wrong track is corrected into the right track by discussing concepts and not at all by talking about syntax or any of that stuff. So you'll see no code, and a lot of talking will take place before eventually, towards the afternoon, you really, really do see the thing working in complete, intimate detail. So enough of me and therefore the introduction. This safe harbor statement is always in our slide deck, but seriously, it has no consequence on anything I'm going to say today. And I'll just put up that slide there to remind me how to, roughly speaking, approach about the first hour maybe of extempore talking. So here we go. The aim of what I'm about to do at the moment is to make you appreciate and be able to repeat in your mind the characteristics, the properties that any solution to the goal we're talking about, namely zero downtime application upgrade, must have. Okay? Let's say I'll put you in the mental space that we all were at Oracle headquarters before anything was even designed in detail, and of course, therefore, before anything was implemented in what eventually became EBR. We knew before we started what properties it must have and why it had to have them. And that's what I want to do for you at the start. And even before I start on that, I'll be using the terms upgrade and patching a lot, and at times I might just blur the distinction and use them almost interchangeably. But I will now make a formal distinction between the two, specifically as they are used about applications. And even when I use the word application, I have to be a bit careful because different people mean different things by the term. Certainly, we're not talking about the kind of app you don't download and run on your cell phone for maybe finding out the weather in different parts of the world. We're talking about this classic, familiar Oracle database-backed OLTP type of thing, where there's a community, a large number of concurrent users. All of them do relatively small operations, inserting one row, that kind of thing, and the whole thing works concurrently. That's the thing I'm talking about. And such an application these days is usually brought to the end users by having a database, of course, and then having some kind of middle tier stuff with a connection pool, and then having a browser at the user interface. There might be robotic clients as well as there are human clients. For the purposes of explaining things, it's sufficient just to think of the human clients. So that's when I talk about application, I mean the whole shooting match, everything, all the parts that deliver the end user experience. Now, as far as the Oracle database is concerned, you may hear me use, or you will hear me use a rather long phrase, which is the set of artifacts inside the Oracle database that implement the back end of your application. That is a rather long-worded expression. And sometimes when you hear people say the word application, they mean that. They mean exactly the set of artifacts that you, the development shop, designed and put in an otherwise empty Oracle database exactly to be the back end of your application. They might say that's application and forget all the stuff out of the rest of the picture. And loosely speaking, when I talk about online application upgrade, I am using the word application that way, but I will give you the whole picture across the whole stack. Why do I use the word artifact? Why am I so fussy there? Because in the most general case, when you first install the back end, the Oracle database back end of your application, you do a number of things. You create tables, you create indexes. They're just objects that you see in DBA objects, views, synonyms, PL SQL, but you might have constraints. It's wrong to call them objects, but they are things you make, so they're artifacts. They're not listed in DBA objects. And in some application installations, tables that have been constructed explicitly to be part of that application backend also are populated with data, which data is used in some way to control the application. So there's another kind of artifact, rows in tables, that were put there by the conceivers of the application in order to be part of its functionality. And the word artifact is kind of non-specific and covers all that lot. Still with me? Right, so imagine when an application is first conceived and comes into being, and let's imagine the ideal world now, where there's a really good first-class team of clear-thinking engineers who are eventually going to build the thing, and where there's a very professional and clear-thinking team of people representing the whole user community, or the business, as they sometimes call it. And some negotiation will take place, you know, and an understanding will be reached of what this new thing that doesn't yet exist is supposed to do. And that understanding will encompass both a reasonably good picture of the information requirements, which in the old days at least, one always thought of in terms of an entity relationship model, and the functional requirements as well, like, you know, hire employee, that kind of thing that we heard about so much in the old days as well. While that is expressed, that mutual understanding would be expressed and reviewed by both parties in some kind of document that traditionally would be called the requirements spec. Yes, maybe the in Norwegian, the kravspecifikasjon. I expect you would say it similarly, but with a slightly different pronunciation of that second word, which I won't try to imitate. That then is a very abstract kind of thing. It doesn't even really describe the properties of the solution yet. It's just clear statements about what needs to be done. And then would come the external design. You know, this, if you've got a big enough imagination, you could picture the whole thing finished before anything has been done, yes? And that second piece, well, let's just call it the external design. Then, of course, that would be discussed and agreed with the commissioning people, the business, and off would the engineers go and do stuff and produce the actual real thing that conforms to that external spec, yes? And that would involve the production of a design document and then the implementation of a system along the lines of what the design spec proposed, yes? You, I'm sure, know all this inside out. That's the good way of doing things. I'm sure you've had experience at least of applications that come into being by not doing that at all, just by total chaotic messing around. Maybe some of you have had the luxury at least once in your life of having seen the whole thing in the ideal fashion done that way. Now, the final thing that's deployed on the first day it's deployed then, nominally, is exactly what's required. It exactly meets the bill because there's been so much discussion and mutual to and froing and so on. When it then is taken into use, you could expect that it really is very good. Notwithstanding that, it usually happens that after some period of use, days, weeks, little tiny faults are noticed. Maybe in some particular interaction path, suddenly there's an error and the screen goes blank or something of that sort. Or you just get, worst case, an actual Oracle error coming out on the end user's browser. I've seen these things happen. I've seen it happen in internet-facing applications built by Oracle Corporation, believe it or not. Now, such faults, they always are called bugs, aren't they? And the attempt to fix those bugs is always referred to patching. And the critical, I think, property of the endeavor of patching is that it aims to restore the state of affairs in your deployed application that you thought you had already. You know, you really thought it was all perfect, and it seemed to be perfect. Then you got these problems, so you're patching it to get it to be what you thought it was already, to get it to be what it ought to be. And critically then, when you do such patching, the end user shouldn't see any difference of significance, shouldn't see any semantic difference. But they would expect, in the case of these bugs that were anyway occurring somewhat randomly, that the chance that used to be finite, non-zero, of such a bug would just drop to zero. That would be the only change they'd notice. Still with me? That's what I mean when I talk about patching in terms of the total application. And you can imagine that patching such an application would involve, in many cases, making some changes among that total set of artifacts in the database that implement the back end of your application. Doubtless, there could be changes in other tiers as well. Now then, what about upgrade? Upgrade, it's very tangible. It's very easy to understand. After the deployed system has been working for some time, it usually happens that there's some discussion and some interest in making it do yet more things. Maybe outside requirements change, new things come along, or maybe it was anyway a phased delivery and you got something out first and you had a sketch idea at least of the things that you hadn't done yet. So in order to bring that desired new functionality to the overall application then, the existing requirements doc would be progressed to its next version. Version 1 of the doc would go to version 2. Who knows if there's change bars or anything like that, but you know what I mean. You could read version 2 of the spec and understand both what a complete system would look like, who was just delivered according to meeting those requirements, and the changes that a deployed system at version 1 ought to undergo to become version 2. And there'd be a corresponding revised version of the external design, a correspondingly revised version of the design spec, and then ultimately, in the ideal world, two kinds of code deliverable would be produced. One would just instantiate this whole system in a completely virgin environment, as it ought to be at version 2. The other would take a installed and indeed populated with data occurrence that conformed to the spec at version 1 and change it to become version 2. And having done that, the end users would expect to see noticeable differences. Maybe the whole flow of steps that were conceived of to do some particular task would be rearranged in the light of feedback coming from use. You know, there would be dramatic differences in general between the end user experience in version 1 and version 2. And that's deserves of the word upgrade, okay? Now, just so that you don't think I'm a bit confused here, I promise you I'm not, the terms patching and upgrading are also used about the Oracle database itself. And the critical difference there is that though a patch is meant just to fix bugs and an upgrade is meant to introduce new functionality, Oracle database has a strict moral contract such that all application code, in other words, I should say, every extant set of artifacts designed to be inside an Oracle database, to be the back end of an application, must function without any detectable difference after an upgrade, okay? That's a special spin on it. Though the upgrade brings all sorts of new things, it's meant to be exactly compatible with the previous version, yes? Now, it's not the same with application upgrade. People don't feel that same moral contract. You know, something was, the steps were this, and the colors were this, and the layout was this, and you don't like it, and you change it on purpose, accepting the fact that end users will be a little bit perturbed and have to relearn things. Yes, it's just the way the world is. You see that every time you finally cave in and say, oh, all right, then I will, when you're urged to accept an update for your cell phone, for example. Everything that you used to doing one way has changed on a whim almost there. Never mind functional specs or anything like that, just some designer thinks that red's better than blue and that's it. But you're with me there, yes? Now it's that, you might think I'm going on and on and on, but that's a hugely critical thing that informs that picture. That picture is meant to be a taxonomy of the goals that sort under the high-level goal of high availability, sometimes called maximum availability. You might want to call it uninterrupted availability. You could want that as much as you want, but no one has yet found a way to deliver uninterrupted availability in the face of everything that you might find for, I think, fundamental reasons that you could understand in a moment. So within this HA space, goal space, we have a crude division between everything physical and everything software. And the extreme example of some kind of event in the physical world would be an earthquake, a flood, or a bomb dropping on the data center. We've heard that scenario a million times, and we know the basic principle of survival there. The basic principle is to plan in advance for that eventuality by having a complete copycat version of your running system somewhere so far away from the running system that the odds of the same earthquake or the same flood or the same bomb damaging the standby are vanishingly small, yes? And how does the technology work? I don't really have to speculate. I'm sure you all have got a clear enough idea. You know, mechanisms exist to let you, before you thought of having the idea, and then when you have the idea, set up this whole standby and bring it up to some level of continuous tracking, yes? One-way continuous tracking. And then when the bomb drops, the general hope is that end users will suddenly be unable to do the next button press. There'll be some kind of hourglass or something like that. But before they'd even have time to register that this is worse than the normal random delays you get from anything coming over a network, we hope that the things behind the scene have moved everything over, failed it over, as we keep on hearing, to the other system, and then the users continue having experienced what they usually call a brief brownout. But when they're in the new world, they don't even know that happened. Yes, that's the whole critical point, that the end users, robotic or human, detect no difference after the event occurred and the remedy has been taken in experience between what they were having before. And critically, all the data that they knew was there is still there, yes? And so it is with the upgrade, the full-on upgrade of Oracle database itself, moving over to the software side of things, yes? I'm sure you've heard of this scheme that's usually called transient logical standby, yes? Everyone roughly familiar with that? The basic idea is to capitalize on that idea that is used for disaster recovery, but when your second system is fully tracking, take it off tracking for an interval, meanwhile taking care of all the redo that's accumulated on the other side from that moment on, and then make radical changes in the structures in the database, whatever you do, so that its internals have changed quite a lot, but so that it still offers a container within which that total set of your own artifacts will function without visible difference, yes? And that involves doing the tracking using a different scheme. In the basic disaster recovery scheme, it's just raw blocks that go over, and that's sufficient. But in this one where you've changed the major version of the Oracle database, there has to be some intervention in the stuff coming across. I'm sure you've heard logical standby. It involves mining the redo and constructing SQL and transforming the SQL and so on, yes? Now again, in that situation, the aim is to pause the whole population and to then restart it on the other side. And ideally to do it as briefly as you can so that you can fob them off with some explanation that it was some network glitch, nothing to do with the database at all. And, 20 seconds, I think anyone would completely be prepared to believe that a sudden 20-second, oh, nothing happening, and then things back to normal was the problem of the local network provider or the router in your hotel. That's just what we've come to accept. So I think you see that when the aim after the event has been and gone is that the end users detect no difference whatsoever, you've got an opportunity for doing something. And if you can manage to achieve your goal with a tiny brownout, that's good enough. And going to really, really, really zero downtime, as I'll explain the term means in a moment for the application itself, I mean now the total application itself, that's harder and you don't need to do it. So let me move straight now to the real proposition of zero downtime application upgrade. And I want to make you really see what the challenge is and why in this picture, it's the bit down the bottom, it was the last piece of the jigsaw puzzle to fall into place. The whole point is that everything that's on the screen so far has the same property that the event, whatever it is not going to cause any semantic effect in the running application, and correspondingly, the whole users of the thing would expect to see zero change, zero detectable change after the recovery from whatever event it was. Yes. Now, for the first bit of the next little section, picture a pretty trivial internet-facing application. I would expect that you all use such a thing. I certainly do. I periodically, maybe most twice a week, sometimes less frequently even than once a week, I log on to the application that presents itself at a browser that lets me see the balances in the 3 bank accounts I happen to have with a local bank somewhere near Oracle headquarters. And in that I can see the incomings and outgoings in each account, and if the level in one is too low, I can move money across from a different one. You know, that kind of thing? And periodically, I get an email from the bank, and they say, we're going to do some exciting stuff at midnight on Saturday, and we'll give you this, and we give you that, and it's all wonderful. And by the way, the system will be unavailable when we're doing that. And normally, I don't perceive that as a problem, in that I'm not trying to do some actual work with this thing at midnight on a Saturday. What I do perceive is that next time I use it after such an event, everything has changed in the way I was talking about before, right? Now, how long is my typical interaction? This is a key point. It's something like 20 minutes, I would say. There's a definite start of session. Actually, with such an application, you really, really authorize yourself. They don't even let some authorization linger on from last time you were doing it. You have to meet a challenge, do this and that, and now your session has started, and you're always advised to log out at the end. And if you don't, they will forcibly log you out anyway after some time. But if you keep on working with a reasonable pace, you won't ever get kicked out until you decide you're going to finish. And the typical duration of such a session, if you think about it, is easily 20 minutes. And it's the same, by the way, if you're shopping on the internet. Why? Because quite often you've got a roughly expressed goal in mind, but you realize when you're halfway through doing the things, you need to look up some other facts. You need to check this, check that, check a calendar, see where you'll be, see if you have enough money for this, that, and the other. You know the kind of thing. Or if you're internet shopping and you suddenly see some shiny new thing that you feel life is incomplete without, but you hadn't noticed that before, you probably go off and Google this and that about it and so on. In other words, you can get distracted. And the intellectual challenge of deciding whether or not you really want this shiny new thing might be so severe that you need to go upstairs and get a cup of coffee and come back down while you still consider you're in the same session. I'm laboring the point a bit, but I think you know what I mean. If at any moment during that experience, which you intend to continue until you're finished, you were kicked off, you would say, well, this is no good. This system certainly doesn't have continuous availability. It's certainly exhibited an interruption in its availability. Okay, just hold that thought. Now, another thing is if I did at midnight on Saturday, not having read that email, try to use the app, and I saw a big sign that said, sorry, unavailable, we're doing some maintenance, again, I would feel the same frustration. In other words, what I'm trying to say is if someone says our goal is to have zero downtime in the face of genuine application upgrade across the whole stack, using upgrade exactly the way I meant, with semantic noticeable change, then you've somehow got to manage two things. One is all sessions which are humanly conducted and which have a natural duration have to continue until the human user decides it's time to finish. And at any moment, if anyone wants to start who isn't yet in the middle of a session, they must be able to start, right? Those two things must be true in the face of your meeting this zero downtime upgrade goal. Well then, there seems to be now a paradox, an immovable object and an irresistible force. The irresistible force is exactly the drive to go from version n to version n+1 and produce all these dramatically different behaviors, right? However, the immovable object is two. One is you can't kick anyone off halfway through, and the other is you can't hold anyone back who's trying to start. So the question is, how do you respond to that irresistible force? How do you get from n to n+1? And if you think about it, it has to be like this. You prepare version n+1 somewhere in secret, somewhere off to the side, because you can't make any changes in situ, because then people would see the difference and they wouldn't think that their experience was continuous. They would think that things had been interrupted. So you've got this whole version n+1 fully formed on the side. Now, how on earth does anyone start to take it into use? There's only one way that's conceptually feasible, and that is when the moment's arrived, when you're sure that the next version is fully formed, you somehow need to throw some switch so that from that moment on, everyone who starts on n+1. Meanwhile, those who had already started in n continue in n until they're ready on their own schedule to finish. So I think I've deduced for you, just using ordinary prose, ordinary normal natural language, I've deduced from the fact that the statement of goal want zero downtime application upgrade, where upgrade means exactly what I said. It implies meeting a different goal, which is having the old and the new versions, the n and the n+1 versions, capable of concurrent use for some period, yes? Which period will have a duration on the order of the average longest duration of end user sessions. You still with me there? So what does this imply in the kind of application we're talking about? Let's shift our example now away from the banking account to the kind of thing that these poor people who staff a call center use. You know what it's like in a call center. There's an army of people, they're all sitting at their screens. What they type is recorded somewhere, and clearly it's a database of record that all these different people are affecting, yes? And we can imagine it's an Oracle database. That's such a system. So put the pieces together. That call center, or at least the organization who has the call center, have a new version required with new functionality, semantically different, exactly because this was required. It was important to move to the next version. Yet, so that they have zero downtime, which is also important to them, they must allow people working on the old to continue until they log off, maybe their shift, you know, 2-hour shift or something like that. And they must also let people who want to start, when they're just starting their shift, log on without ever any delay, right? But they're all manipulating one corpus of information. So now consider this scenario. I'm sure you've all experienced it. You phone up such a call center, you go through the annoying menu choices, and you eventually get to a human being. In doing the menus, you'd provided a whole load of facts about yourself, and then the human being insists on, for your security, making you give the same bloody story again, yes? And if you're used to this, you will demand to get a case number. You know, you keep on, give me a case number, blah, 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 give me a case number. And you write down eventually, when they concede and give it to you, you write down that case number because you know what's going to happen next. When you've finally agreed with the support person or the call center person that you're ready to start on the real story, they've got your life story and the size of your shoes and the color of your eyes. Now about my problem, the phone goes dead, yes? You suspect that they just got fed up with you and hung up because you've been a bit too aggressive. But let's say it was just an accident. Then you phone back. And if it's a good day, you know, you'll say, I was cut off, this is the case number. Blah, blah, right, I've got all your stuff. Little double check, yes, this is you, now go on. What was the problem? That's where it works out well. And maybe the thing drops a couple of times during that. Or maybe you have to research something and phone back in half an hour and then, yes? Right. So now what would happen? How does it work? You know, first time you're speaking in this transition period to someone who happens to be using the old, yes? Well, they record some facts. Then the line drops. Then you phone up again, and this time you get an agent who happens to be using the new. You expect to see the same facts. And then you work a bit, and then that little interaction stops, and then the next person you get is on the new, yes? So what you can see then is that this second system that was set up, here's the first, here's the second, somewhere in secret, is not so secret that it's got its own island of data. The data in this one and in this one must be mutually synchronized in both directions. Yes, that's the only way it can work. Let me just introduce another notion at this point, refactoring. Let's, for the moment, get a little bit specific and think inside the Oracle database, and then we'll come back and join the dots. I'm sure you all know about the famous cod and date and the principles of formal logic and set theory and on and on and on and on. And if you were discussing how some information requirement might be met when you'd identified an entity type with maybe 15, 16 attributes, if you found that someone who was planning the table decided, oh, 15, oh, that's such a big number, and anyway, it might be 16 tomorrow, I'm just going to have a pair of columns, attribute name and attribute value, you'd start, I hope, to get uneasy about that, you know, and you might try to tell them, just picture the SQL that you'd need to do any typical operation. Compare the SQL that you'd need to do that with the SQL that you would have if it was just a flat conventional table with a column for each attribute. But for some reason, you lose, and it ends up like that with the attribute name, attribute value pair, with all the problems it brings, you know, flattening all things to a text representation, losing data arithmetic, all that stuff. You can imagine that at some point in time, you get the opportunity to go, told you so, intervention is required. It's accepted that one needs to refactor the data. In other words, take a table which has got many, many rows and plenty of other columns and just 2 columns here, into one that's got far fewer rows and a column of the proper data type for each of those 15 or so attributes, yes? Now, the aim there is to do a transformation from a narrow, tall table to a wide, short table, but to make no semantic change, to preserve the semantic content of the source, yes? That's what we mean when we talk about refactoring, yes? And you can imagine such a thing being a part of the picture in either, for that matter, an application patch or a full-on upgrade. You would, if that was the only thing you did, you could plausibly call it a patch. But if you'd involved it as one thing, you may as well do it now while you're doing other things in an upgrade. Well, it could be that too. So in this call center situation with the synchronization, I think you can see then that whatever algorithm you invent to do the refactoring from the old shitty one, sorry, I'm on tape, aren't I? From the old unfortunate one to the new, less troublesome one, you need to do in reverse as well, right? Yes, you need mutual bidirectional synchronization, which might well involve some kind of transformation to express this refactoring business. Still with me? I hope. Yes? Yes? Right then. So put all those pieces together and now imagine or remember that all these applications have various data rules. It's in their nature. And without being too formal about it, one obvious data rule in the business world is very, very, very conveniently implemented by having a unique constraint on a column, right? Maybe one of these 15 guys has got to be unique in all its values. Of course, if you did it in the attribute name, attribute value fashion, it's going to be harder for you to implement that semantic effect, but you could still manage to do it. You know, you'd need triggers or something like that, but it's doable. That would be another reason for favoring going over to the new representation. Now, at the risk of seeming to go slightly off track, I'm not. Imagine this experiment. Perhaps all of you have done it. If you haven't, you should do it just once for sport. Here's the experiment. You've got your own Oracle database. It's on your own laptop. You're in full control. You create table T of a text type, and you put a unique constraint on it. That's all you need. Table T, 1 column, text, put a unique constraint on it. Then you get 2 SQL Plus sessions. In the first one, you go insert into T values cat, and you do not commit or roll back. You just leave it hanging there, the statement executed, but you haven't yet committed. There's a unique constraint. You go over to the other session, and you say the same thing, insert into table T values cat. What happens? Anyone like to tell me what happens, just so that I have a break from speaking for a moment?
A big old wait.
Sorry?
A big old wait.
Yes, yes. I think if I heard you correctly, the second one simply waits. Then when the first one does one of 2 things, something happens. If the first guy rolls back, the second guy simply goes ahead as if there'd been one of those inexplicable hotel network outages, right? You never know. If, on the other hand, the first guy commits, then the second guy, as soon as the commit has gone through, gets the error that they would have got had that cat in the case in question been put in yesterday. It's again, they just had that hourglass like the hotel network is troublesome, right? Now, who knows how that happens? It's magic. But it does happen, and you all know it happens. You can rely on it. In other words, you can rely on the fact that such data rules, which are declaratively established, and by extension, even the ones that you established programmatically with triggers or something like that, they are imposed, they are enforced in a fashion which is completely robust in the situation that there's high concurrent multi-user, multi-user concurrent activity. Yes? This is just what you expect from Oracle. It's been like it since the birth of time. Why am I making such a fuss about that? Well,